my side. Okay. So in this discussion, we will have a discussion on object-oriented programming strategies, and we will address the concerns like what is a class, what is an object, and what actually makes your application development in object-oriented programming possible. So far, the applications what we have written are sequential. They are executed in a sequence. Alright. You start from the main method start executing, and sequentially every statement is executed one by one, and the result is generated at the end of the method. Once the method is at end, you get some response. So this kind of application is kind of a sequential kind of application where you have every functionality piece tied to sequence from the earlier functionality. All right. In object-oriented programming systems, what the essence is, you will define the objects based on your overall functionality. You segregate them based on your business need, and as per your requirements, you will design the classes. If you have a need to, for instance, let's take this example itself. You have a need to translate the real world entity called object into a programming construct account. So this account you will design as a class, and you will specify some properties to this class. Now, every object in real world, it has some properties. Okay. So in object-oriented programming strategies, you define the properties of your objects inside your class, and classes are used to design your objects. And once you design the objects based on the definition, based on your design, you can instantiate any number of objects to that, any number of objects. So let's take an example of a general principle. Let's assume that I have a application where I have to use a person. Okay, let's assume a person. In your system, there are some data types, like you have integer, you have char, you have log. So these data types are understood by your system, by your object, by your Java virtual machine directly. You just have to declare that I have used integer a equals to 10. Your system understands that what you want to say, that these are your primitive data types. But what if you want to use something which is not in the primitive data type? Like for instance, you want to use a person in your application. Alright. This person is not understood. You want to say, let's assume I want to use a person whose name is Ravi. Okay. The system does not understand what this means. So you have to define this thing, that you have to define what Ravi is, what a person is. Okay. For that purpose, we design class called person. Alright, and you have to frame definition of this now. Now what you want is, as per your application requirements, what do you need to be in the person class? So like every person has some name, this person will have a name, every person will have some age, this person will have some age. Okay. So I am defining the properties. Let's assume I have this two properties for now. Only these two properties are important in my application. So I'll define these two properties, and I will define some behavior as to what the person should be able to do. What are his abilities? What are the functions what it can carry out? For instance, every person can talk. I can say this person should talk. I'll make it as a behavior, as a function. Alright, and this function does not return anything. I'll make that function as void. And every person walks. I'll make this person also walk. I'll just have these two functionalities defined in my person class. So this is how I proceed with the definition of defining my class, defining my object. So before I actually, there are no objects created so far. This is just a definition of your object. I'll give some statements here to print line person talking. Okay. Similarly, I'll say over here person talking. So what's done so far? I wanted to use a object of type person in my application. So for that purpose, I defined this person class and its properties, name, age, and its behaviors, talk, walk. So every object will have these things. You have to define a class. You will have name of a class. You will have properties, and you will have behavior. Alright. This is how your classes are defined. Now the properties will be instance variables of the class. These variables are also called as instance variables. Alright, and these are called as instance methods. Now why they are called as instance variables and instance methods? Because they are part of every object. Once you define these things in your class, now you instantiate objects. Now every object what you instantiate will have these things in common. It will have a name, it will have some age, it will talk, it will walk. So this is a kind of definition, a blueprint. Once you have a blueprint, you can instantiate any number of objects for this. All right. Now in my application, I want to actually instantiate this one, person demo. So this is my application, and I'll have, as usual, the main method what I used to have. Alright, and I'll save this with the name person demo. So this is my application. This person demo is my application, and in this I have to use this person object. Person p equals to new person. I instantiate that. Right. And once I define, for using this person object, I have created the definition. Now after I instantiate the object, I can now call p dot I can set the values of the variables, instance variables. I can set the values of the instance variable p dot name equals to, right, and I can say age, fine. So what am I doing? I am defining the, in fact I am defining the properties of my person. I am instantiating the values. I'll say instance. Alright, I am instantiating these variables, and now you can even call the methods p dot talk, p dot walk. Alright, so let me have the example run here. So as usual, I'll say Java C person demo.java. Did I miss something here? Okay, yeah. I did not terminate this with a semicolon. This statement has to be terminated. What else? Okay, the name of the method I missed here, it to be main, static void main. Did I do this, by the way? How can I do this? Yeah, and now it's not a statement. Okay, this has to be, yeah. Oh, it's fine, it's compiled. If you happen to notice your drive in which it is creating, let us see this person. Person.demo is created as well as person.class is created. So it is creating these two classes separately. Because this is one class, as we have defined it as one class, and this is another class, and the source file is one. The source file is person demo.java, right? After compilation, I have two classes. One is person class and one is person demo class. And when I run this, I'll have to run with the class which has got the main method. Alright. So for that purpose, I'll do what? I'll say Java person demo. Right. This, it says person talking and working. So this is one example of defining a class, and according to that class definition, you instantiate the objects. Now I can use these instance variables here outside the definition of the class. I can also use the instance variables here. Just I'll concatenate this string. I'll add this string to the existing string, person talking plus, I'll say p dot, in fact I'll have to say just name, the name of the person who is talking. I will not use this here. I'll say name plus talking. And I'll say the same thing here as well. Alright, so compile this, run this, talking and working. Now, as a matter of definition, as I told you that once you define your uh, blueprint, that is your class, once you define that, you can instantiate any number of objects for that. So I can do the same thing. I can do p1 equals to new person. Alright, and again I can ask this person some functionality, p1 dot new. I can set the properties, p1 dot age equals to, right, and I'll say it's not p2, it's p1 dot talk, p1 dot walk. And if I now run this application, this is not supposed to be in quotations, this is an integer. Compiled, and when I run this, there you see I get two objects. Okay. So by definition, what we have done is we have defined this class. Firstly, this is our class, and based on this class I can now instantiate objects. I can create one object here, one object there, one object here, and every object when I instantiate, this is not person, this is not name, this is person, this is person. Properties has got the properties. I have two properties, name, age, and behavior. I have talk and walk. Alright. So after this definition, I can instantiate any number of objects. Now this object I instantiated, this object reference was P. This object instance variable name was Ravi, and his age was 40. This object reference was P1, and name here is age is 49. So every object will have its own copy of the data what I have declared in this example. Every object has got its own copy of its data. For that reason, we call that as instance variables and instance methods. Now you have seen that this method is taking the data what has been given to this object. When I say p1.talk, it is taking the data of p1 itself. It is not taking the data of p, because that's a different entity and this is a different object. So both are different objects, and you can distinguish between these two objects with respect to this image. And this will give you a clear idea that you have two separate entities, two separate objects, and these objects are having their own data, and when these objects behave, they behave on their own data. They execute their own data. They don't interfere with others' data, the other objects' data. So that is the goodness of having object-oriented concepts used in your system, that you can distinguish between different objects in your system, and accordingly you can give every object its own data to operate on. So I hope you got this concept of what class is and what object is. So when you design a class, think about the objects that will be created from that class, and the object state is called as instance variables, and behavior is called as methods or instance methods, to be specific. They are instance methods because they operate only on that specific instance. They do not operate on the other instance. Instance is object itself. When I say instance, it means I'm referring to object, instance of a class. You know the basic definition what an object is. Object is an instance of a class. So these are two instances of my class person. Alright. Now in your object, this is how you instantiate your objects. Creating object to access your class. You use the new operator. You call the constructor and you instantiate this object. Once the object is ready, you can call any of the accessible methods by using dot operator. Once your object is ready, you will actually call it by using P or P1. Those are the references. Alright. Now what happens behind the scenes is when you instantiate these things, there are two portions of your memory.